Before starting on this next bunch of problems, I just wanted to do a quick review of inequality notation, all the different symbols that we use to represent solutions of inequalities. So when we're using inequality symbols that have lines underneath them, saying that a number could be greater than or equal to or less than or equal to, then on a number line we use a closed dot on top of our solution. And with interval notation, we use square brackets. If our inequality symbols have no line underneath, meaning just greater than or just less than, then on the number line we use an open dot, and the type of brackets we use are round brackets. And then also on top of that, if we're needing to use the number infinity, within our interval notation, infinity always has round brackets next to it. Infinity will never have square brackets. So on problem 7, we're supposed to solve the inequality and then write our answer with interval notation and graph it on a number line. The way that we solve inequalities is the same way that we would solve equations. We want to move things from one side to the other. We want to isolate the variable. We want to move all the constant numbers to the other side. There's multiple first steps for this problem. I'm going to go ahead and start by adding 4 to both sides of the inequality. That leaves me with 3x on the left side and then 2x plus 11 on the right hand side. Then I'll bring the x's to the left hand side of the inequality by subtracting 2x from both sides. So that gives me x is greater than 11. So on my number line, since it's just greater than, it's not greater than or equal to, I'm going to use an open dot to mark where 11 is. And this says that x can be anything greater than 11, so our arrow on our number line needs to head to the right towards positive infinity. With our interval notation, we want to go from lowest to highest, and so the lowest possible number for our solution is 11, and the highest, we don't have an upper limit, so the highest would be positive infinity. So here's what our interval notation would look like. We would use a round bracket next to 11, and then we would write a comma and put infinity to show that our solution increases forever. On the next problem, we're asked to do the same thing, solve the inequality and write the solution with symbols and interval notation. In this case, our first step would be to distribute the -4 to the x and the 5. You could also divide both sides by -4. I just chose to do it this way instead. So that gives me -4x minus 20 is less than or equal to 2. Next thing I'm going to do is add 20 to both sides of the inequality sign. That gives me -4x is less than or equal to 22. And then the last thing that we have to remember, the only real difference between solving inequalities as opposed to solving equations, is that if you multiply or divide both sides of the inequality by a negative number, then the inequality sign has to flip. So in this case, when I go to divide both sides of the inequality by -4, the direction of my inequality sign is going to change. And so my final solution for this is x is greater than or equal to -5.5. I'm going to use a closed dot on my number line where -5.5 would be. And again, this is saying that x can be greater than that number, so my number line would have an arrow going to the right. With my interval notation, I would use a square bracket next to -5.5, and then show that my solution goes towards positive infinity. And again, we have to use a round bracket next to infinity. Problems 9 and 10 are just practicing writing interval notation. Problem 9 is going to use a square bracket because of the line under the inequality sign. Problem 10 will use a round bracket because there's no line under the inequality sign. In the case of problem 9, x is greater than or equal to -4, and so our solution heads towards positive infinity. On our solution for number 10, x is less than 9, which means x is going to anything lower than 9, so towards negative infinity. And again, our interval notation is always written so that it goes from lowest to highest. And so in that situation, the lowest value would be negative infinity, and the highest value would be the positive 9. Problems 11 and 12 are practicing using number lines. On number 11, I see a square bracket next to -5, which means I'm going to use a closed dot. On number 12, I see a round bracket next to the 7, which means I'm going to use an open dot. In the case of number 11, -5 is listed first, meaning it's our lowest value, and then it's heading towards positive infinity, so our arrow would head to the right. On number 12, negative infinity is listed first, and then 7 is shown as our highest value, so I would mark an open dot on 7 and have an arrow going to the left.